When we run a code, we can have actually multiple exceptions, and every exception of them is of a different type. Consider that we have the following file, data.txt, with these 3 lines. And let's run this code without any try except. I would like you to try to figure out as much as you could all of the exceptions that might happen here. So develop inputs and say, with this input, this program will work well. But with this input, this program will crash for this reason. And with this input, it will crash for this reason. Try to be a good inspector for the code, as a good reviewer, and find out all of the possible reasons. Let's go. If you try to input something like data.txt, which is a file nearby and existing, and variable n1, it is a string, then it will go very normal. The index will be converted to integer. We will open the path, and then we will read the file, split all of the lines, and print the list at this index. The list has only 3 items, so list of 1 is going to be very good, and then we are closing the file. We didn't use the whether statement here, so we have to close by ourselves. If you try to input something like data.txt only, then we will have an error at line number 3. It will be unpacking issue, so a value error will be thrown because we expected 2 items, but we only passed 1 of them. If you try to pass a file that doesn't exist, you will have a problem in line number 6. It will be file not found error, which means this file doesn't exist. On the other side, in some machines, definitely in your machine, there are some directories that you shouldn't access as a user. You have to access them if you are only administrator. On my Linux machine, something like /boot/efi is a path that requires permissions. If you try to path this directory, you will get something like permission error. If you try to pass something like data.txt and string hey, you will have value error in line 4 because we will not be able to convert the hey to integer. If you try to pass something like 1000, then we will have an index error at line 8 because the list has only 3 elements. In a similar way, -1000 will provide us with also an index error. However, -1 is a proper negative indexing. So the list has 10, 20, 30. This is the value 30. As you see, we have too many different errors: value error, file not found error, permission error, index error. These are too many. If you just try to do the try except, it will catch them. But what if I would like to do special handling for different errors? This value error, file not error, permission error are actually classes ready for you as part of the Python built-in exceptions, and you can use them. So here is how we can use the try except in a stronger way. This is our block of code, the main one. And then observe here, we have different except statements. Every one of them has a specific error. So the code goes as following. If everything here is perfect, all of the except lines of code will be ignored. If there is else or finally, there might be considered. Now, let's say that we have a value error. Then the value error will try to check, is it except a value error? Yes, then it goes here. Let's say that we have a file not found error from line 6. If we run this code, it will go iteratively. Is it value error? No. Is it index error? No. Is it file not found error? Yes. So this one will be handled. If it's index error, again, go here and here and here, and that's it. Okay, what if you didn't provide this line at number 17? If your error isn't part of these 3 errors, it will not be caught. It will again be thrown and crash your system. So you have to be careful. That's why I'm adding here this except one. This except one is a very generic, like a DAD exception. Everything must eventually be caught here. So if it isn't value error or index error or file not found error, please catch this one here. For example, the permission error wasn't handled in this 3. If we try to give the path for the permission error, it's going to be caught here. But if line 17 doesn't exist, this will cause a crash for our program. Now, what if there are like a couple of exceptions that I would like to handle them in the same way? For example, let's say that the value error and the index error should be treated together. I don't need to make a block for every one of them. You can make it like a tuple, and it has to be a tuple in Python 3. So you make this tuple here and this tuple here and pass a list of the indices. Then now it will be handled here. Again, it is a tuple. Okay. In the previous codes here, we have something wrong. Can you figure it out? The mistake is if there is a problem here in any of these lines of code, we jump into the except and the file here will not be closed, and this is a big mistake. So the right way to handle it is to add a finally. The finally will check if the file is going to close it, but it might be opened or might not be. If line in index line number 5 was the error, file will never be open. That's why I'm defining here and assigning here file to none and checking here. If it isn't none, then again close it. Remember, there was a statement. The with statement is capable of closing always a file or a resource, even if there is an exception. If you now look back to that guy here and did try, but instead of opening the file, you wrote with path blah 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 and did whatever. If any mistake happened here, the file will be handled. That's why it is the Pythonic and the standard way to open file is to use the with open. The with statement will guarantee for you solving this problem. Let's also consider a new syntax here. I'm defining here except and also putting what we call base exception. Except and except base exception are the same thing. They are like the highest level of exceptions and it can catch everything. The second thing here is the as e. Exception, the exception that is thrown is actually an object. So it's an object and it has attributes and it has function and all of that. What if you would like to get some extra information from this object? Like I would like to get an object instance. I would like to get a variable assigned to it. You can use the as e. So this exception now will be here as an object e. Now you can, for example, get the error message using the str e. It will return for you the error message. So now I can catch the exception and I can still print the message, or in some advanced cases you can now get inside this error object and do whatever with it. Finally, the exceptions follow something called inheritance. Inheritance will be a section in the OOP part. We will come back again to the exception to learn two things, to understand the effect of this hierarchy on the exceptions. For example, if you define an OS error, after it file not found error, the file not found error will never be called. We will know why later. The second thing is how can I define my own custom exceptions, like I would like to find something specific to my business. Familiarize yourself with these names, it's good for you. And also I would like as a reading activity, please go ahead and read this built-in exception and read this short summary. You will pass with many things that you don't understand, totally okay, just skip all of them. I just would like you to familiarize yourself with the section. In the future, you might read about the Python error number. Remember, we said before that there are two approaches when it comes to exception, the error codes and the handling exception mechanism. Actually, every exception has a unique number, but it's a bit platform dependent, so you have to use some like global keywords. You don't need to know about that at the moment, but I wanted you to know in the future there are error codes for the exceptions, so this is a future reading. And this is also another minor future reading for you to read about it. That's all.